Now we'll see an example of students who are asked to make predictions further down the sequence of the pattern based on their understanding of the unit of repeat. In this video, we see Heather Lett, another wonderful grade 3 teacher, facilitating the students' thinking. Recent studies suggest that an important part of developing algebraic reasoning is the ability to identify the mathematical structure of a repeating pattern and to use that structure to make predictions about the pattern far down the sequence, which is an early form of constructing a mathematical generalization. In this example, students use their understanding of the relationship between the numbered columns and the elements in the column to be able to make far predictions. One prediction was based on a 5-column core, and students were able to predict any column by knowing the last number. So, for example, all columns ending in 5 or 0 would be the same as would columns ending in 1 or 6, 2 or 7, 3 or 8, and 4 or 9. Of course, this thinking only works for multiples of 5. We wanted to ensure students understood that this wasn't the case for all patterns, so we also had them explore a pattern with a 4-column core. This led to a much deeper understanding of the nature of repeating patterns. Most of the repeating patterns found in elementary curricula are based on the variation of 1 or 2 attributes of a series of items, for example, red, blue, which are usually presented horizontally. The focus of instruction tends to be on identifying the pattern core and determining what comes next in the sequence. In our study, students were introduced to more complex repeating patterns that were made up of 2-dimensional pattern cores, columns and rows. Copying, designing, and creating the patterns with beads on a loom supported students to analyze the complex structure of the pattern. The focus of the analysis went beyond identifying the unit of repeat and predicting what comes next, to being able to use the structure of the pattern to make accurate predictions further down the sequence. Physically creating bracelets provided an opportunity for students to have to think beyond the 20 columns of the given template. Looming meant that the repeating patterns were physically growing, and students reported internalizing the repetition of the pattern in terms of sequences of columns of beads, which led to an ability to formulate generalizations. This thinking then transferred to more artificial school math questions, as we'll see in the next example.